Let's look at the midpoint theorem and solving for unknowns. So here we have x at the bottom, it's a side. I know that this side will be twice the middle line here because the middle line joins one midpoint of AB, which is D, to the other midpoint of AC, which is E. So because the midpoints are joined, it means that DE is parallel to BC, and DE will also be half of the value of BC at the bottom. So BC then will be 10 meters because DE is 5. This is because of the midpoint theorem as our reason. The next one here, we're given two sides here that are equal, 12 and 12. And we're also given that the third side is parallel. So this means that the other side here should also be equal to each other because of the converse of the midpoint theorem. So if the top is 36, then the bottom part should also be 36. So x equals 36, and your reason is converse of the midpoint theorem. We have the next one here. Let's solve for the unknown. So x first. I can see that x and this 90 here are in the corresponding angles position. And I can say that these angles are equal because of corresponding angles because of the midpoint theorem as well. This line in the middle here is joining the midpoint of the hypotenuse and the midpoint of the side here. So it means that these lines are parallel. So I can use corresponding angles. If I'm solving for y now, y is a part of the small triangle on the top. Let's use that. The triangle on the top, we just showed that it's a 90-degree triangle, so we can use Theorem of Pythagoras to solve for y. The value here is 5, because that's equal to the bottom section here, and the value here is 3, because that's equal to the bottom section here. So if I'm using Theorem of Pythagoras, y squared is equal to 5 squared minus 3 squared, and that will give me an answer of y is equal to 4. If I solve for z now, z is the bottom length of the triangle here, and I know that will be twice the value of y. We just worked out that y is 4, so z will be twice 4, which is 8, and that is because of the midpoint theorem. If we given a rhombus PQRS, let's find the length of PO. PO will equal to OR because the diagonals of a rhombus bisect each other, which means that these two values here are equal. So PO will also equal to 24. Find the value of SRP, so angle SRP, which is this angle here. I know that angle SRP is equal to this angle here, 20, because the diagonals of a rhombus bisect the angles. The next one, find the value of QOR. So QOR is equal to 90 degrees. This value here, QOR. I know this because the property of a rhombus is that the diagonals intersect at right angles. Find the length of QO. So QO is here. QO is in this triangle here, QOR. I'm going to work in this triangle to find the length of QO. I know that this angle in the middle here, O, is 90 degrees, so I'm going to use SOHCAHTOA or trig to solve for QO. I'll choose tan because tan of 20 is opposite over adjacent. So opposite 20 is QO and adjacent to 20 is OR. So tan of 20 will be QO over RO, and RO is 24. If I cross multiply, QO will equal to 24 times tan 20, which is 8,74. The next one, if M is the bisector of PS here, And if n is the bisector of SR here, find the length of MN. So I will say that MN is equal to half of PR. And MN is going to be half of 48, which is 24. And this is because of the midpoint theorem.